Good morning, everyone, still. As Barry mentioned, my name is Ian Palmer, Head of UK Specification at Airflow. You probably noticed our logo around the facility. We've also got some of our products at the back there. So I'm just going to give you a quick introduction to Airflow before I go on to the presentation. I actually have two little presentations. The first one just on our products and our airflow measurement devices, and the second one is to do with MVHR versus air conditioning. So just background on Airflow. So Airflow Developments Limited, we were formed in 1955, and we started up in a small factory in High Wycombe making airflow measurement devices. So we made the first inclined manometer, and funny enough, we're still based in High Wycombe today, so we're just up the road. Feel free to come and visit us. I was going to say that at the end, but I may as well say it at the start. That's our head office there on the left, and on the right, the image is our Air Academy, so we have all of our products on display and working. It's a fantastic facility for training of our airflow measurement devices, our products, our MVHR systems, fans, etc. The image in the middle there is our Airflow Germany office. So we have subsidiaries over in Airflow Germany, in Cologne, and also in the Czech Republic. And just to give you some idea of the products that we manufacture and produce, so on the commercial building side, we produce MVHR systems, so mechanical ventilation heat recovery units, air handling units. We also do a range of fluid dilution fans, hot gas fans for OEM products. And then on the residential side, which we're very well known for in the UK, we produce intermittent extract fans, continuous extract fans. At the bottom there, you may recognise one of the fans. This is our Icon, one of the best-selling fans in the UK. The Icon has a slow-opening iris shutter, very stylish extract fan. So if you haven't heard of Airflow before, the chances are you may have come across that fan before. We also do decentralized mechanical extract, so, and also MVHR systems for residential properties and a range of ducting and accessories. So as mentioned, you can see that at the back. So just briefly, I wanted to talk about our airflow measurement device. So this is the Mensura, Latin for measure. It's a powered airflow meter, and it has to be UCAS certified. I actually have the model over here, so I just wanted to quickly open that and demonstrate it to you as well. So yeah, it does come in this nice little suitcase. It's a lot lighter than it looks, and it's usually easier to get out. There we go. So you just simply pop the hood on the end. You can use it without the hood, but usually it's better to use it with. There's various different hoods that it comes with. You put it up over the fan, make sure it's sealed, and this will give a digital reading of the airflow in litres a second. So the features it has, turn it the other way so you can see it. So you've got the scroll button, which is the big black button labelled number 1 on the screen. The information display, which gives the litres a second. You've got number 3, which is the measuring side, which is the hood. You've got the air inlet at the bottom, or the exhaust, and you've also got the point of pressure measuring, number 5, and the connection to the temperature sensor motor. Number 7, which isn't on display, there's different other hoods available, larger hoods available. So the powered airflow meter. So moving from the supply to the extract flows is easy. There's no need to change the unit configuration. The airflow direction is automatically detected. There's no calculations that are needed when you're checking the airflows. The system pressure within the airflow meter is automatically compensated. So flow measurements, they're easily to read, easy accessible. from the digital screen, which is built in. There's also an adjustable handle to move it into position. So I've actually been out with our own airflow engineers. So we go to site, test a number of our fans for our contracted clients to check that they are performing once they're installed. Because there's one thing that the fan says that it can do on the box compared to actually when it's installed. So taking this along to site, after a full day's work, your arms are a bit tired, especially if you're measuring fans that are always installed in the ceiling, because you do have to hold it up there for a few seconds to get the accurate reading. The machine beeps once the reading is confirmed. So yeah, it's mainly for installers and service engineers, so to accurately measure and measure the supply airflow rates. So the instrument can measure the airflow and the temperature, and it's commonly used in the ventilation industry for commissioning, balancing flow rates, adjusting the valves, checking the installed against design flow rates, and checking the flow rates in compliance with Part F of the building regulations. Volume 1 is for dwellings. And in Volume 1, Part F, Section 1, it's got a couple of tables here, Table 1.2 and Table 1.3. You may just be able to make out some of those figures, some of you at the front, but in this table, it's minimum ventilation flow rates. So they can be higher, but they can't be lower than that, otherwise it fails the building regulations. And yeah, important to reiterate, this is installed performance. So yeah, you can't just pick up the fan and say, right, it does say that it can do 15 litres on the box, but can it do it once it's installed? So yeah, some different flow rates there that you can see, and you just need to make sure that the fans or the system, MVHR system, is meeting the minimum installed performance. Also in Part F at the back, in Appendix C, there's a completion checklist and commissioning sheet. And again, this is the measured flow rates. So the installer has to put here the actual flow rates when they've used a measurement device to measure the flow rates. So again, not just what it says on the box, it has to be the performance. So in summary on this product, the Mensura, it's a powered airflow meter. It's used by installers, service engineers to accurately measure and supply the airflow rates. The unit will need a UCAS certification of calibration. The design is low weight, so it is designed for one man to take around with them. Fully automatic with a digital display, provides a clear reading, and it helps to ensure that you've met the building regulations Part F. So that was the end of that one. I said nice and brief. So I'll just open the other one, other presentation. There we go. Okay, so I've done the intro to airflow already. As you can see, a nice image there of the lady letting in fresh air, or what we believe to be fresh air. So, yeah, outdoor air pollution. We all know it's a problem. We can see it. You can physically see it on cars, fumes, gases. Yeah, in busy cities, obviously, it's more obvious. But the pollution isn't just outdoors. Automatically moved the slide there. So yeah, we do spend up to 90% of our time indoors. Some of us maybe even more than that now, where we're working from home a lot. So the indoor air quality becomes more important. So there is other pollutants inside the building that are built up by the fabric of the building and the occupants. And it's important to both dilute and remove those airborne pollutants from the space. So in educational buildings, in offices as well, it is important that we do improve the indoor air quality because it has a detrimental effect on our concentration and productivity levels. So common pollutants found inside the buildings, you've got VOCs, CO2s, and you can see there, yeah, the image is all about the affecting the concentration and productivity. So it is important that we dilute and remove these pollutants from the space. Otherwise, the air will become pretty toxic, and then we get what's called toxic home syndrome, for example. So then it has an effect on the occupant's health, well-being. So it's important that we're bringing fresh filtered air in from outside and extracting stale polluted air. So when it comes to air conditioning, you see everyone's familiar with these types of cassette units. There's a bit of a misconception that air conditioning is replacing ventilation, or if air conditioning is in place, we don't need ventilation. But the problem with air conditioning is it is just conditioning the air. It's not removing those pollutants from the space, and it's not managing the humidity levels. So there is still issues that are going to be caused in the building. So yeah, the air conditioning units as well, not great to look at. So they often are exposed, particularly these types of cassette units. Whereas the ventilation units, they can be hidden, they can be installed in the ceiling voids, they can be installed in plant rooms, they can be installed on the rooftop. They're out of the way, but they're doing a very important job. They're actually improving the air quality and also filtering the air. So yes, when we say we're bringing in fresh air from outside, that air still needs to be filtered because of all the outdoor pollutants. So when you're using a ventilation system, it is bringing the air in, but it's also filtering before it's going into the building. Filtration levels, there's various different levels of filtration you can get. Most units have standard coarse filters in. You can get much higher grade filters depending on the level of air quality you're aiming to achieve. Building regulations and the European standards are all pushing for better ventilation, better filtration. And then you've got to consider the costs. So the costs of heating and cooling your home. With ventilation, you can have heating and cooling coils built into the ventilation system, so then they can do both the heating and the cooling, so as well as the ventilation. So this here is just an example of a ventilation unit. Yeah, again, these wouldn't be necessarily exposed. Some buildings they could be. Depends on how stylish they want to be. More of an example there of a ventilation unit installed in the ceiling void. So this particular model there has built-in heaters and coolers. So it is both bringing the fresh filtered air in from outside, extracting the stale polluted air, and also conditioning the air, the supply and extract. So yeah, coming towards the end, the heating and cooling side of things doesn't just need to be done with an air conditioning unit. It can also be done on the ventilation system. Noise is also important. So if you have your air conditioning unit and it is in the room, you will some of them tend to be a lot noisier than others. Whereas if you have your ventilation system installed, again, somewhere else, not actually physically in the building, in the room, the noise levels are a lot lower. Mentioned CO2 earlier as one of the main pollutants, but yeah, it's what we are now all familiar with, is one of the most common pollutants inside the building. So again, with a ventilation system, you can control and remove those CO2 levels. but with an air conditioning unit you can't. Also with a ventilation system, you can have it connected to a building management system. You can also control them via the internet, so you have full control of the system. You can monitor all the units from one location, even on your tablet or phone or laptop. So it gives you full remote control to that system. Whereas again, with most of the air conditioning systems, it is almost a manual control. So you would have to control it in the room. Just to finish, so mentioned the Airflow's Air Academy. We do have our MVHR products on display. We also have our full ventilation system running the facility there. We are just up the road. Our units also have heating and cooling coils built in, so they do a full ventilation and condition of the air. But yeah, I didn't say at the start the reason why I wanted to just cover this, because when I'm talking to people outside the industry, talking to friends, talking to family, I'll tell them I work in the ventilation industry, and they'll say, "Oh, that's air conditioning, right?" And then I've got a choice. I can either bore them to death onto the differences of ventilation and air conditioning, or I can agree with them. Most of the time I tend to try and teach them and tell them that air conditioning and ventilation are different. But yeah, that was the kind of idea behind this. And that style of presentation with just images, no text, Petra Kucha style, it's designed to sort of keep the audience not bored by loads of text, but really you're supposed to spend 20 seconds per slide, so it was skipping through as well, so I didn't have to overrun on the time, so I don't get any signs hold up. But it does mean that I have finished 10 minutes early, so now I have to answer lots of questions from you guys. But yeah, if you have any questions in terms of ventilation, in terms of our products, in terms of our airflow measurement devices, feel free to fire away.
Awesome. Thank you very much. We can show our usual appreciation. Maybe we've got time for a question or two. Does anyone have any questions? I've got a quick question.
Yeah,
why would we want to use comfort cooling over air conditioning? We have a couple of our American friends in today, and they'll say to me, comfort cooling? Why bother putting air conditioning? What's the benefits?
Well, yeah, I guess the biggest benefit is that where you've got air conditioning, you've got all these individual units per room, whereas with the ventilation system, you could have just one unit supplying to the whole building, supplying to various different zones throughout the building. So you've got less maintenance, because you've just got one product. And it's also saving you energy. So if you've got the ventilation system in place, if it's got the heat recovery with it, then obviously you're recovering the heat in the winter time. So you don't necessarily need that air conditioning unit. You can just utilize the comfort heating or comfort cooling to top that air up to a more comfortable level. Nowadays, I think with the heat recovery systems, Airflow's units are up to 95% efficient on the heat recovery side. So the air coming off the heat exchanger in the wintertime, if we just took some examples of temperatures, so if it was -5 outside and say 21 in the room, the air coming off those heat exchangers is still going to be around 18, 19 degrees. So then you only need to top up that air to a more comfortable temperature.
Yeah. Great. Okay. Is there any other questions? One at the back.
Sorry,
that's right. Standard shout. Standard shout.
Absolutely. I suggest that potentially this is to try and get through the overheating rates as well as the 59 calculations. Do you do design specifications for that, or is that something that would still rely on mechanical engineers?
Yeah, thanks. Good question. Yeah, at the moment, we as manufacturers, some of the design responsibility does fall with us, but yeah, the preference is that they should go with an M&E designer because they're qualified designers. At the end of the day, we're a manufacturer, but we can help with the designs on that side. So yeah, particularly with the overheating. So we do help with a lot of designs with our house builder clients. So they will send us the designs that have been done by the architect in terms of the house, and then we would design the ventilation system in for them.
Okay, there's one at the front here.
Hi, Elliot.
I know you didn't quite mention that air conditioning doesn't need ventilation under regulations, so it's not a choice of one or the other.
Yeah.
You need the ventilation regardless.
Yes.
The options are ventilation and air conditioning, or ventilation with cooling.
Yeah.
So, but I thought it might be worth you mentioning about the cool air recovery as well over the summer, because obviously if you cool the building down, you've got the cool air recovery from the MVHR the same way as you have warm air recovery. So
Yeah.
you're reducing the load on the cooling system as well, and therefore that's where you get your efficiency saving over air conditioning.
Yeah, exactly that. Yeah, so that's one thing that always gets forgotten about because of the name of the product. Because the name of the product is a heat recovery unit. Everybody does forget that it can also recover the cool air. So when in the summer when it's warmer outside than it is inside, the units can utilise the cooler indoor air to cool down the air coming in from outside. So in terms of cool recovery, they do that via the summer bypass of the units. So most units, Airflow's units, they have an automatic summer bypass. Utilises temperature sensors which are built inside the unit, measures the air coming in, measures the air going out. The unit, using its intelligent control system, will decide when that summer bypass needs to be open and closed. They are fully modulating as well, so it doesn't have the bypass doesn't have to be 100% open or 100% closed. So the unit works to achieve the desired temperature automatically. It is important to note there is other products out there that have a summer bypass facility, but they have it's a manual process. So it then relies on the homeowner or the owner of the building to manually go and open or close that summer bypass. And we know at the moment in industry, MVHR isn't that familiar to most homeowners. So if it is a manual process that is relied upon, I think at the moment we can be pretty certain that most homeowners are not going to know when to turn it on or turn it off. So it's better to have that automatic bypass in place. So yes, you do get your heat recovery and cool recovery.
Okay. One last one then from Edwin.
Oh, yeah. Yeah, thanks. On the commissioning side, it is down to the installer. So yeah, we don't do our own commissioning, but we do have engineers that can go to site and assist with the whole control setup and everything. And we are also on hand to assist remotely. So one good thing with the airflow systems, with our Adroit units at the back there, they have internet control, so you can actually log into the units remotely. So if it was something that the installer or commissioner run into an issue, and they just gave us a call, we could actually log into the units remotely and help them diagnose the issue there, or alternatively, we can send our own engineer to site to help with that.
Okay, thank you very much. We show our appreciation.